Hey guys, my Rishabh. Last time we have talked about the integration approach of kinematics, and today we are going to talk about the free fall acceleration. So, free fall acceleration. So, what is free fall? If you wanna understand it, that if you like toss up an object at some height, and if you eliminate the like this, if you toss some object like a ball at some height, so if you eliminate the effect of air resistance, there are no air resistance. So then you would find that the object accelerates downwards. Right? Object accelerates downwards at certain constant rate. It has some certain constant rate, and the rate is 9.8 meter per second or 59.8 meter per second square. So, and this rate is called the free fall acceleration, and this rate is called free fall acceleration. So, the acceleration is independent of whatever the characteristics of an object, like mass or density or shape. This whole thing, the acceleration is independent of this, and it is always same for all the object. It is always same for all the object. So, if you wanna example, then if there is a vacuum chamber, vacuum chamber, and if there is an apple or a feather, if you drop it at a same instant, same height, t equal to 0, and same height, then it will touch the ground at same time instant. If you wanna test it, you should have a vacuum chamber or something like no resistance zone. So moving on, all this are, we can say it, gravitational acceleration. So the gravitational acceleration varies per area on Earth. Like at sea level, it is 9.8 meter per second square, and at poles it is 10 meter per second square. So this is all the basics of free fall, and if you let us take an example for understand the concept of free fall acceleration. Let us take an object like a ball, and let us take it on an axis, not on an axis. This this will create a wrong perception on your mind that it is somehow on a height. Let us take an axis like this. This is y direction in negative, this is x in positive, and ball is at here, and this is some height, So here I have a question about free fall. That object is at 48, height is 48 meter, and what is the acceleration to the gravity? G equal to 9.8, and it is falling downwards. So this is the touching ground, and let the fall begin at t equal to 0 with initial velocity v0 equal to 0, and we are going to use equation to solve in here. The question is what is the time at which the ball touches the ground. So we have to use the equation which have the time component. So what was the equation? The equation was x minus x naught equal to v naught t minus half gt square, or in this case we are taking y minus y naught equal to v naught t minus half gt square. In this case, here y minus y naught is a displacement in a negative direction, so we take it always as a negative quantity. So let's put some value on it. So y is 48 meter, the distance. If you have confusion about it, you can take it as y2 minus y1. Then y1 equal to 0, or y naught is equal to 0 here, and y2 is equal to 48 meter. So y2 minus y1 if you have some confusion, and I am going to take y minus y naught. So y equal to 48, y naught is equal to 0, and v naught is equal to, v naught means initial velocity, equal to 0 at t. We have to find t, multiply t minus half. G is negative or not, yeah, we are taking negative here, and also we are taking negative here because the direction is negative, and g is negative because direction downward, and t square. Then what it will become 48 equal 0 into t is equal to 0 minus plus 4.9, this 4.9 into t square, and what it will become, t square is equal to minus 48 upon 4.9. So t equal to plus minus 3.1 second. Here we are choosing the positive sign because it started at t equal to 0. So moving on, let us apply some condition here. Let make a table like what is here, and let divide it. Divide it as t, y, and v and a. So at t equal to 0, y equal to 0, and v is also equal to 0, but acceleration is 9.8. At t is equal to 1, the ball is here. What will we have to find y, and we also have to find v, and the acceleration is always 9.8. So how we can find y? We are going to use the same equation, y minus y naught equal to v naught t minus half gt square. So here we have the what we have, y and v naught or v. So let's apply y naught is equal to 0. We don't know v naught or v, into t equal to 1 minus half, g is equal to 9.8, and t is equal to 1 square. Let's take it an equation. Equation 1. But we also don't know about v, so we have to find the v quantity. So for this we have to use the equation like v is equal to v naught plus gt here. Then v equal to v naught is initial velocity, which is 0, plus g is 9.8 into 1. So what will it become? V equal to 9.8. and also at t equal to 2 second, v equal to 0 plus 9.8 into 2, which becomes v equal to 19.6. Here we are taking negative because the direction is velocity is in negative direction, and at v equal to 3, t is equal to 3, then 9.8 into 3 equal to 29.4 meter per second, meter per second, and meter per second. So here we have found that v equal to 9.8. So putting this equation in equation 1, what we get? Y equal to v is minus 9.8 into 1 minus half into 9.8 into 1 square. What we will get? This is also negative. I forgot about it. 9.8 minus minus plus, and it is 4.9, which will give minus 4.9. Then what will y become? It is also negative, minus 4.9 meter. This is meter per second, meter per second square, and this is second. Moving on, at t is equal to 2 second, what it will give us at e equal to minus 9.8, and what we have, t is equal to at 2 second, v equals minus 19.6. So we are going to apply that. Then y equal to apply it on equation 1. Then what we will get? Minus 19.6 into 2 minus half minus 9.8 multiply upon 2 to the 2. Then it will become y equal to minus 9. So y equal to 39.2 plus minus minus plus, this will become half into 9.8 into 4, and what will be the 39.2 plus 4.9 into 4, and it will become minus 39.2 plus 19.6. Then y will become minus 19.6. So we have v equal to minus 19.6 and y equal to, but we have got 19.6 minus 19.6. So moving on, at ball t is equal to 3 seconds, e equal to minus 9.8, and v equal to what we have calculated, v equal to at 3 seconds, minus 29.4. So we have to find y here. Y minus y naught equal to v naught t minus half gt square, or v, not v naught. Here we have y minus 0 equal to, what is the value of v? 29.4 meter per second. So minus negative 29.4 meter per second into t equal to 3 seconds and minus half g is equal to negative 9.8 meter per second square and t equal to 3 second square. So what we will get, y equal to 29.4 into 3 equal to minus 88.2 plus, because negative positive, half into 9.8 into 9, and y will become minus 88.2 and it will become 4.9 into 9, and then y will become y is equal to minus negative 88.2 plus plus 44.1, which will give y equal to 44.1. So moving on, we have calculated y equal to 44.1 here. So we will get 44.1 in negative direction. So moving on, we also have to calculate the final velocity here, because we have known the time is 3.1 second, and we also have known about height, which is negative 48 meter, 0.0 meter or 48 meter, and we don't know about the velocity, and we also have the acceleration, which is negative 9.8. So if you wanna find the velocity, if you have time and distance and also acceleration, then we are going to use the formula of v square is equal to v naught square minus 2g into y minus y naught. Here we have v naught square is equal to 0, because it is initial velocity, which is equal to 0. 2 into 9.8, we know about the y, which is negative 48 minus y naught is 0, and what we will get, v square equal to negative, this is also negative, positive, negative, and we will get 2 into negative 9.8 into 48, and v square become, when we multiply with it, we will get 940.8 in negative direction. So v equal to, put under minus 940.8, which will give plus minus 30.67 meter per second. And here we are taking the negative sign, because velocity is in negative direction. So moving on, so this will become v equal to negative 30.67, which is nearly equal to approximately equal to 31 meter per second. And if you want to change it in kilometer per hour, then kilometer per hour it will become 31 into 60 into 60 thousand, which will give you nearly 111.6 kilometer per hour, or nearly 110 kilometer per hour. So that's all for today. I hope you have learned a lot from here, and sorry for the mistakes and lag in starting, but it is also a great concept, because a lot of time we use the Newtonian mechanics in this type of questions, but we don't know we don't know about how to use kinematics in this type of problems. So I hope you learn, and thank you.